Okay, I'm starting definite integrals. How we write definite integral and what's the difference between definite and indefinite integral. Definite integral has this form from a to b, f of x dx. So this is definite integral, while indefinite integral, it is, we can write down as negative infinity to positive infinity, f of x dx. We just don't put negative infinity, positive infinity. Okay? This is indefinite integral. So what's the difference between them? That we, in a case of definite integral, we limit the area of integration. Let's say we want to find the area under this curve, A and B. Okay? So that will be our definite integral. So, and the A and B is a segment or range that we call integration segment or integration range. Okay? All right. So how we're going to solve a definite integral? So we practically going to write down integral a of b f of x dx, which is going to be f of x, okay? And then we are going to apply the values of a and b, because a and b are included. See, I have square brackets, a and b. So it's going to be a, it's going to be b, and we are going to be equal. This is going to be equal f of b, I'm plugging value of b instead of x, and minus f of a. So this is we call Newton-Leibniz formula. Okay? All right. Is there always definite integral? No. Not always. Let's bring example where definite integral does not exist. For example, if I take integral from -2 to +2, and I have dx, or maybe, let me put it better, -5, -2. And I write down dx over square root of x, right? There is no integral on the range, -5 and -2. Why? Take a guess. Because this integration segment area is not part of the definition of function, because we cannot have a negative value of x under square root. I cannot plug under square root x -5. I cannot plug under square root -2 for that very reason. Okay? Another example that definite integral does not exist also. Here we have -2 up to 3, and we have tangent x dx. So since we have integration on the interval -2 and 3, the tangent suffers here a gap at the point x is equal -pi/2, right? Remember the graph of integral, of tangent. This is, looks like, so this is 0, this is half a pi, this is negative half of pi, this is pi, this is 3 over 2 pi, let's say. This is pi, negative pi, this is at the negative pi, it's going to be here, so it's going to go right here. So at the point of negative pi, the tangent is not defined, right? Therefore, such integral does not exist. Tangent x dx on interval negative 2 and 3. Okay. Next question. Can the definite integral be equal to negative number? Yes, it can. And can be nth negative number and 0, and even may turn out to be infinity. Okay, which will become indefinite integral. As you noticed here, it's the low limit we have. Here we have upper limit, right? Can it happen that lower integration limit be greater than upper integration limit? Okay, well, let's see. We can have, let's say, for example, we can have from 6 to 0 and 1 minus x dx. Okay, in this case, what we are going to do, we are going to do the following. So I'm going to put negative sign in front of integral, switch the boundary, which means switch the limit. 0 comes here, 6 comes here. 1 minus x dx, yes. And to get rid of this negative sign in front of the integral, just put negative to 6. 1 minus 6, write down x minus 1 dx. So we can do such type of manipulation. And from here, I can write down the formula. Not formula, but property, if you wish. So which means integral a to b f of x dx is equal negative b to a. Let me write down this nicely. b to a f of x dx. Okay. All other properties are identical with the indefinite integral. That's where constant can come out, or the addition of functions is equal sum of two integrals. Okay, we can use also substitution. Everything is possible. We can every property, everything we are using with calculating indefinite integral, we can use with calculating the definite integrals. One more thing I would like to invite your attention on. Let's assume we have integral f of x dx from a to b. This is equal integral a to c, I'll explain in a minute, f of x dx, and plus integral c to b, f of x dx. So what does that mean? That means if I have, let's say, some kind of, let me see, this area. So I'm breaking down here, this is my A, this is my B, Okay, so sometimes it's easier to break down, sometimes it's easier to break down into two integral at this point C, which is going to be integration between A and C, and then integration between C and B. Let's solve a couple of basic examples. Number one, we have integral from 1 to 2, 2x squared dx. Okay, so how are we going to solve it? Very easy. Constant we're taking out, 1 and 2, and we have x squared dx, and we are getting, so it's going to be 2, and x squared, it's going to be x cubed over 3, right? 1 and 2, the range, which means I'm going to put 2/3, take out, and x cubed, 1 and 2. This is equal. Since 2/3 is a common factor, it's going to be x cubed, it's going to be 2 to power 3 minus, and then x is 1 to power 3, and we are getting 2/3, 8 minus 1, and we are getting 2/3 times 7, which is equal 14 over 3, and which is equal 4 and 2/3. Okay, next question. We have integral from -2 to +4, 8 plus 2x minus x squared dx. All right, so to solve it, we are breaking down. So integral of 8, which means 8 I'm taking out, I will have -2 to 4 dx, plus 2 comes out, integral from -2 to 4, it's going to be x dx, and then minus integral from -2 to 4, x squared dx. Okay, this is going to be equal 8x -2 4 plus 2, so x is going to be square root, is going to be x squared divided by 2, right? Well, divided by 2, I will put it here, -2 and 4, and minus, it's going to be x cubed divided by 3, I'll put here 1/3, -2 and 4. Okay, this is equal 8 times, so plugging x is 4, first one, right? I'm working on first piece. So 4 minus -2, you have to be careful here. Next, since this is gone, I have only x squared, it's going to be plus 4 squared minus -2 squared, and minus 1/3, gonna be 4 to power 3 minus negative 2 to power 3. So this is equal 8 times 6 plus 16. Let me write down the way so it can be seen better what is what. So here we got 8 times 6 and then plus underneath this 4 squared minus negative 2 squared. It's going to be 16 minus 4, okay, and then minus 1/3, and here I will have 64 plus 8. Put parentheses, hold on. 1 second, parentheses and another parenthesis. And we have 48 plus 12 minus 24, and this is equal 36. Let's evaluate next integral, not solving, just evaluate, because there is nothing to solve. So we have pi and pi, so practically in 1 point, right? There's no range. Sine x dx. Take a guess how much it's going to be equal. Of course it's going to be equal 0, right? Because the sine function is defined at the point x is equal pi, and the upper and lower limits are of integration are equal. Therefore, their difference is going to be equal 0. Yes? All right. Next one, number 4. Let's assume we have integral from 3 to 0. As you can see, upper limit is, the bigger number is sitting as a upper limit, lower limit. So we are going to flip it, right? X plus 2 dx is going to be equal negative 0 to 3 x plus 2 dx, and if we solve it, it's going to be negative x squared over 2, 0 and 3, right? And then plus, it's going to be 2 and x, right? Derivative, integral of 2 dx, it's going to be 2x, 0 and 3. Yes? And negative sign in front. So this is going to be equal negative, let me put 1/2 here in front, it's going to be, so 3 to power 2 minus 0 to power 2. Right now, since we just started, I'm going slow, so you can get used to it. Plus 2 times 3 to power 1, okay, there's no power, and minus 0. So what do we get? Negative 1/2 times 9, and then plus 2 times 3 is 6. So we get negative 9 over 2 plus 6. So 9 over 2 is how much? 4 and, oops, in parentheses, see, I almost forgot. It's going to be negative 4 and 1/2 plus 6. So it's going to be negative 10 and 1/2. Okay? All right. And let me solve one more. So to use the one of the cases I explained when we break down AB range into AC and then CB. Remember? This one. Where is it? Oh, this case. Let's use this case also, and I will be done for this video. And then next time we will solve a bunch of definite integrals. So to succeed in definite intervals, you have to know very well indefinite integrals. That's why I spend a lot of time with indefinite integrals, because definite you solve exactly same way as indefinite. It's just at the end you plug the values. That's all. Okay, this is gonna be question 5. And we have integral from -1 to 1, absolute value x dx is equal. So since I have absolute value of x, so this is what I'm going to be. It's going to be -x, right? dx on interval -1 to 0. Make sense? And then plus, it's going to be positive x dx on interval from 0 to +1. Yes? And if you solve it, you are going to get 1/2 plus 1/2, and it's gonna be 1. Okay, I'm done. So thank you for watching, and I'll see you in next video.